Okay, welcome everyone to the June Singularity CE community call. As you might be able to hear, I'm a little bit under the weather, but I'll try and battle through what I'm going to demo today without losing my voice completely. Today, as on the agenda that's been circulated, we're going to demonstrate a couple of things that are kind of in the works for 4.2. So we have OCI-SIF data containers and also being able to push from an OCI-SIF image up to a registry for consumption by other runtimes such as Docker. And really, that second point is about kind of Singularity not being a dead end. You can pull down an image which is built for Docker, but you can also, in the OCI mode, push up images now that were built with Singularity for use with Docker or another OCI runtime. So these are quite powerful things we've kind of been talking about in the past several months when we've covered the roadmap. Again, both of these new features are for 4.2 in the OCI mode. So let me switch what I'm sharing a second across to a terminal. And we'll start off by talking a little bit about data containers. So in Singularity, if you have some data, and here I've got a directory, and it's full of stuff, and I perhaps want to use that data with an application that's in a container, then usually I just bind the data in from the host, or it will automatically be bound in the native mode from the current working directory or my home directory. Now that's great for working with sort of project data, which is stuff you want to analyze with some containerized application. But when you're dealing with software that sort of analyzes data sets, but uses perhaps some reference data, which might be particularly processed specifically for the needs of the application, then we start having situations where there's data which isn't really my own personal data, but sort of goes along with the application. And various people have raised over time the idea of sort of data containers, where it'd be nice if we could distribute the reference data that goes with a certain tool in the same way as we distribute the tool itself. So if I have a sequence aligner for, I don't know, RNA-seq data or genome data, then I might distribute a container which has a tool to do the alignment. And then I might want to distribute reference data, the indices that my tool uses, and typically they're different format between different tools for the human genome and the mouse genome and the rat genome, and really make it easy for people to get these in exactly the same place as you get the tool in the same way. So you don't have to pull a container with Singularity, but then go and trawl off through random websites to download some sequence data and then process it into an index. You just pull the tool, and then you pull the container which holds the reference data that you need for your analysis. So this is the type of workflow we're trying to address here. If we start looking at very simply what we have now in Singularity, with this my stuff directory, what I can do is I can now create a data container using the Singularity data package command. So this packages up an existing file or directory into a data container So in this case, I've got a file now called mystuff.oci-sif, which holds all of the nice things that were in the mystuff directory. And if I want to use this with some kind of application, I can use a --data, give the path to the data container or where I want to make it available. And then if I look inside here, there's the top level of my stuff directory, which I packaged into a data container. So there we go. It's quite kind of simple then to package stuff up into this format. It's an OCI-SIF file. So it's SIF as in we have different kind of sections of things, metadata and data all put in a single file, which is easy to move around on HPC systems. But it's an OCI-SIF, which means we're using OCI constructs like manifests and configs to make it easy to push up to registries and so on. So if I drop out of this container a minute, I can then go ahead and choose to push this data container, my stuff, up to either the Singularity Container Services library, just like I would an application container, or I can also go ahead and even push it up to Docker Hub with just the same kind of syntax as I would use to push an application container up. So that's the kind of simple overview. I mentioned this kind of use case of reference data. So if I go up a directory and have a look in here, I've got an example in which I have some mass spectrometry data. So a protein sample was put through a mass spectrometer, and I've got a bunch of spectra. And the kind of problem we have here is identifying which peptides and proteins those spectra in this file belong to. So there are various tools available to do this kind of matching. One of them is a tool called Crux, which provides, it's kind of a collection of tools really, but it provides something we're going to use later called Comet, which is an application which matches this mass spectrum data to protein sequence databases. So now I've pulled from the library an OCI-SIF container, which has this Crux software in it. But the Crux software needs something to run my spectra against. The idea with data containers is that rather than having to give people instructions how to go to, I don't know, the NCBI website and download some files and decompress them and so on and arrange them in a certain way, we can instead perhaps distribute alongside our software some data containers which have our sequence databases ready to go. So I've just pulled from the library two data containers, and now it's a case of running my application against my input data using the sequence database that's in the data container. And this is what I'm going to do. I'm going to run in OCI mode, and I'm going to use my data container. First, I'm going to use one with a human sequence database in it. And I'm going to mount that data container at DB. And then I'm binding in my input data. So this is the input data I have on my local system. This is my stuff. And here's the reference data, which is nicely packaged up for me in a data container. And then I'm asking the Comet tool to analyze my data using the database, which is going to come in from the data container. And off it goes. So this is going to be quite quick because I'm only searching against human sequences. So in 7 seconds, I've got some output, and we can see where the output went here. So if I look in this file, there's a bunch of things which were identified from my mass spectra data. Now, the advantage of the data container approach is if I now want to, I don't know, run the analysis using protein sequences known across all organisms instead of just human, because maybe I've got some contamination in my sample or it's a mixed sample, then rather than having to go off and find a sequence database, download it, do any pre-processing or whatever, I had it provided to me as a data container. So in this case, this SPROT is the reviewed protein sequences across all species, instead of the previous sequence database I used, which was just human sequences. So I've bound in my data container, a different data container, but I've bound it into the same place. I've run with the same command. And what we see now is that it's doing this analysis on my spectra, but it's taking longer because there are a lot more sequences when we're working across all species data here. So this will take a little bit before it drops out to some output, but hopefully it gives an idea of the kind of flows that we're trying to enable with the data containers work. So are there any questions on this piece before we carry on? Okay, well, that one is running. What I'll hop over to a second is actually show you, if I go back in the web browser, that not only can we use the library to distribute thing, but here's my Docker Hub, right? And there's this my stuff data container, which I pushed up before. So you're kind of free with this flow to use the container services library or Singularity Enterprise, or you can use Docker Hub or any other registry which Singularity can authenticate against and push to. Okay, yeah, any questions at all? Right, we'll move along then to the second topic down here. And what this is about is, as I mentioned at the start, making sure that Singularity isn't a sort of a dead end for containers when you use OCI workflows and things elsewhere. If I jump back into my terminal, aside from my analysis having finished, I'm going to go into a directory here called tar layers, where I have a Docker file. So this is a really simple Docker file where I'm just taking Alpine and I'm doing some commands which don't really do much. They add a group and a user to the container. And then when you run this container, when it's built, it's just going to echo a simple message here. But because we now have support to build Docker files in OCI mode with build kit, we can go ahead and we can run a command. And it's created a file here, test OCI SIF, which I can run in Singularity's OCI mode. Now, what I can't do at the moment is directly run this with Docker or another OCI runtime, nor can I push it up and then directly run it with Docker or another OCI runtime, because inside this OCI SIF file, what we have are the standard OCI manifest and config which describe the container. And those are things which runtimes like Docker and Podman and so on understand. But we have the layers, the file system of the container present in there as a squashfs format file system. Now this is good for Singularity because we can mount it easily on an HPC system. We don't have to extract files out to a directory like you do with the standard tar layers, which are in most OCI images. But it's not compatible with other OCI runtimes. What 4.2 will bring is the ability now, though, to work from an OCI CIF file, which was created with Singularity. And when you push it, ask to push it up with tar format layers. So the kind of standard layers that aren't ideal for working on an HPC system. And we can't kind of use them directly in a CIF image on an HPC system, but they are the standard for Docker and Podman and so on. So let's go ahead and do that. Note here I'm pushing up to Docker Hub in this case. That finished. And I can now take my image that I built with Singularity and that I pushed up to Docker Hub and pull it down with Docker, and then run it with Docker. And there's the output that we expect. So this is exactly the same thing we saw as when we ran the OCI CIF file with Singularity. But we've pushed that container up in a way that it can then kind of go off into a purely OCI world and be run by whatever tooling you want. This is all about making Singularity not just a kind of dead end where you always kind of pull things to Singularity, but they never go off out into the broader OCI workflows. You can now go both ways. We could even take a Docker image from Docker Hub, pull it with Singularity, convert it to an OCI CIF. Later, if that image has been lost from Docker Hub, we could push it back up from our OCI CIF and run it with Docker. So we have the ability to go both ways and fit into OCI workflows more completely now. Okay, any questions on that piece? All right, it's a bit quiet today, but we'll carry on. As I said, these are kind of in development. You can currently create a data container, but the ability to use it isn't merged into the main branch yet. And neither is the layer format option, which I demonstrated on 0.3 here, merged into the main branch. These are things that are ongoing that we wanted to kind of show off for the purposes of attracting any comments or thoughts about workflows. Elsewhere, what's been happening since we last spoke is really some relatively kind of small things. Carlos, who's new, has been working on his first PRs. We now can use multiple environment variable files with the end file flag, so you can specify more than one, and there's a precedence across those. There's an additional option in SingularityConf, and there will be more coming to allow administrators to disable certain namespaces. This is kind of a bit niche, really, but some of the namespaces can interfere with certain strategies for software license managers and things like that. And we've had a couple of people say that users are kind of confused when things start working because they've used some flags and then the license manager stops working and they want to kind of disallow the use of things which could break those flows. So that's the reason for those ones. And then we have some bug fixes, and these are really in a couple of places we had in the OCI workflow. Locations where we could get rid of an intermediate copy of an image or some layers, some temporary files, and just kind of stream data through so we avoid using too much space on the temporary directory. So we've gone ahead and done that too. So that's what's been going on the development side from these two kind of headline features. I'll open the floor now. If there are any other questions at all or any topics people want to discuss, raise your hand or speak out and we can chat about those. Okay, well, in the absence of any questions, we'll call it for today. The GitHub discussion thread, which is here, this page, you can ask any questions on that if you think up any after the call, or if you're watching this on the YouTube recording, please feel free to drop questions in there or in the Slack or the Google group. Otherwise, we'll see you next time.